Today we're going to take a look at the law of sines. So, law of sines has to do when we don't have a right triangle. Up until now, we've been doing right triangle trig with SOHCAHTOA. So today we're going to take a look at, well, what do we do if we have a non-right triangle? How can we solve that? So if we take a look at this triangle, we have a non-right triangle, and we have our height drawn in. And it's fair to say that the sine of angle A opposite over hypotenuse, this would be 90 degrees right here, would be h over b. And if we looked at the sine of b, it would be h over a. Well, we both have h in these, so if we solved for h, we'd have b times the sine of a equals h times a on each side. A times the sine of b equals h. Well, our heights are equal, so we have b times the sine of a has to equal a times the sine of b. And now, if we divide this one by b, and this by a, we end up with the sine of a over little a, sine of b over little b. And again, capital letters are our angles, smaller cases are our sines. And what this turns out to be is what's called the law of sines, where it works for non-right triangles. The sine of a over little a, sine of b over little b, sine of c over little c. And you have to know an opposite pair of sides, a side and angle, to use this. So you have to know capital A and little a, or angle b and side b, or angle c and side c. So we're going to take a look at a couple of these. We're asked to solve the triangle. Well, the first thing we could do here is, well, what is angle C? Well, let's see here. We can do 180 minus 105 minus 33. So we know that this is 42. And now we can use the law of sines. So we know capital angle B and little b. So setting this up, we know it's the sine of 105 over 37.5 equals the sine of 42 over little c. And so let's see, what do we have on this side? We have trig the sine of 105 divided by, what was that, 37.5. So we have 0.0258 equals the sine of 42 over c, little c, side c, and now we solve this. So times c, so c times, I'll put this in parentheses, 0.0258 equals the sine of 42, and then we can divide by 0.0258. 0.0258. So we have this, let's see, the sine of 42 divided by 0.0258. So we end up with 25.94 for this side. Then we can set it up again with our other one. We can use that same ratio, sine of 105 over 37.5, sine of 33 over a, and some of you guys might have remembered this. We could solve it the same way over here. Some of you guys might remember we cross multiply. So 37.5 times the sine of 33 equals a times the sine of 105, and then we divide by the sine of 105. And we could type this all in. So we have 37.5 times sine of 33 divided by sine of 105. And we end up with 21.14. So the next one we're going to look at, we're going to be using the law of sines again, and we're asked to solve this triangle. So we need to draw it out. We have A, B, and C. C is 98 degrees, B is 14, and C is 20. Well, let's see. We have C here is where we know our angle and side. So we'd set it up. The sine of 98 over 20 equals the sine of B over 14. Well, we want to get sine of B by itself. So we can multiply each side times 14. So let's see. We got 14 times sine of 98 over 20. So 0.693. Well, now we're finding an angle, so we'll use that inverse key, the inverse of 0.693. So I can go back here, trig inverse. I'll just arrow up twice and grab that. So we have 43.88. So over here we have 43.88 degrees. Well, now we have that 180 business. So we can do 180 minus 98 minus 43.88. So we have 38.12. And now it's time to find little a. So we have the sine of 38.12 over little a equals the sine of 98 over 20. So let's see, what does that side equal? The sine of 98 over 20, 0.0495. 0.0495 multiplied by a. So the sine of 38.12 equals 0.0495 times a. Divide by that. Sine of 38.12 divided by 0.0495, 12.47. And we've solved this triangle. Now, one thing that we're not going to work too much with, but I just want you to be aware of the vocabulary word, is something called the ambiguous case. So, every once in a while, you'll be given two sides. For example, in this one, this is supposed to be little a over here, this t. This is capital A. So we know that this angle is 30. We know that C is 6. And we know that A is 3.5. But what happens is more than one triangle can be formed. So you could have a 3.5. This could be going slanted this way, or it could be inwards, and it's both 3.5. So if we were to set this up, we would say the sine of 330 over 3.5 equals, well, we don't know what C is, the sine of C over 6. But the only problem is C could either be this angle or this angle. And this is what's called the ambiguous case. And we're not going to get into how you know it's ambiguous. It has two possibilities. The ones we're going to look at will only have one, but I just wanted you to be aware is every once in a while there may be more than one case. So the last thing we're going to look at is the area of a triangle. So we know area of a triangle is 1/2 base times height. So we don't have a height here. So if we draw in this height, how can we find our height? Well, we have a right triangle. So the sine of 42 equals h over 5.2 multiplied by 5.2, and we have our height. So our height is 5.2 times the sine of, and I already forgot that, 42. So 3.48. So we'd have 1/2 times 7.1 times 3.48. So 0.5 times 7.1 times 3.48. So we end up with a height of 12.48. an area of 12.35. Now, we've known that formula for area of a triangle, but on this back page here, you guys have a little some blank room. We're going to take a look at how can we write it without knowing the height. So let's say we have our A, B, C. So this would be little a, little b, and little c. And if we have our height right here, we know it's 1/2 base times height. But what is our height? Well, the sine of A equals h over c. So our height is c times the sine of A equals our height. So a new formula for area would be 1/2 our base times c times the sine of A. So this is also area of a triangle. You have to know two sides and the angle included. So if we look at this one, oops, let's see. We have our two sides and the angle included, so it's going to be 1/2 13.7 times 8.2 times the sine of 62.9. And we could type that in to our calculator here. 0.5 times 13.7 times 8.2 times the sine of 62.9. And we have 50. So we'd have 50 centimeters squared. You could also find it by drawing in a height to either one of these two bases. So we could draw in a height here. So as long as you draw in a height to either one of these sides, you could figure it out as well. So here's our height, and we could calculate out h, and we could do 1/2. Our base is 13.7 times height, and we could use SOHCAHTOA to find that height.